Hello everyone. Welcome to this Physics 102 laboratory project presentation. My name is Durza Gökçe and I'm a freshman student at Bilkent University studying in Electrical and Electronics Engineering department. In this experiment, I investigated how magnetic force depends on electric current using a simple coil. When an electric current flows through a wire, it creates a magnetic field. In a coil, this magnetic field is concentrated inside the coil, and its strength is given by this equation. Here, the magnetic field depends on the current passing through the wire, the number of turns, and the length of the coil. This magnetic field can exert a force on ferromagnetic objects, such as paper clips, placed inside the coil. As the magnetic field increases, the force acting on these objects also increases. Combining these relations, we see that the magnetic force depends on the current. This is the main relationship tested in this experiment. The setup consists of a small coil connected to a DC power supply. Paper clips were placed directly at the center of the coil to test the magnetic force. For each current value, I added paper clips one by one until the coil could no longer lift them. This allowed me to estimate the maximum lifting force. Each measurement was repeated 3 times and averaged. The measured mass was converted into force using this equation, where G is 9.81 meters per second squared. The force values were expressed in millinewtons for better visualization. This graph shows magnetic force versus current. The data follows an approximately linear trend, and the best fit line shows that the force increases with current. The slope of the graph represents the force produced per unit current. The average percentage error is approximately 5%. The deviations are mainly due to measurement uncertainty, small variations in placing the paper clips, and fluctuations in current. Since the forces are very small, even slight disturbances affect the results. The slope of the graph depends on factors such as the number of the turns and the geometry of the coil. Since a small coil was used and there was no solid core, the magnetic field was relatively weak. This explains why the forces are so small. In conclusion, the experiment confirms that magnetic force increases with current, in agreement with theory. Although small deviations exist, the overall trend clearly demonstrates the relationship between current and magnetic force.